Hi everyone, welcome back to Coding with Bharat channel. So, as promised, I am going to discuss the next important concept that is very frequently encountered in coding interviews, which is prefix sum. So, first of all, what is it? Why do we use it? When do we use it? Let's try to decipher all of that one by one. So, I'll give a very simple question to you in the beginning, and we'll try to solve that in the brute force way, and then see how we can optimize it with this beautiful technique. So let us consider that we are given an array like this, right? So right now the array might seem like a small one, but in fact it could be a huge array containing up to 10 to the power 5 elements, right? So yeah, containing up to 10 to the power 5 elements. So let's say now you are given different queries, right? And each query tells you to calculate the sum from a given value L to a given value R, right? So for example, one query could be that let me calculate the sum from, let's say, position number 2 to position number 5. So what you would do, you would go into the array 0, 1, 2, this is the second position, and you will run a loop. So let's say we'll run a simple loop for int I equal to L, I less than equal to R, I plus plus, and I'll just add the array of I to this sum. So yeah, it does auto capitalizing, but for, yeah, basically this would be like this, right? So anytime you get a new query, a new L to R, what you do, you run a loop from L to R, get all of its sum into a variable sum, and just print it, right? So this would be the brute force way of doing this particular problem. But let's talk about the time complexity of this a little bit. So let's say if you have q queries, for every query, in the worst case, it could be 1 to n. Give me the sum of all the elements. Or some removing some elements from the beginning or some elements from the ending, right? If you are thinking that, okay, if every query is 1 to n, I'll store the total result. But even with that idea, it might be some elements less from the start, some elements less from the end, and so on and so forth. You can make n number of cases and you'll not be able to handle all of them with less time than O of n. So in worst case, this approach would give you the time complexity of q into n. That for every query, we are going to run a loop of n, right? So if you don't know about time complexity, it's very simple. You just count the number of steps that you are doing, right? So in one query, you are doing n steps, going through each element and adding it, right? Then in second query also you'll do these n steps. So in q queries, you'll do q into n such steps, right? So basic maths. Okay. So this is q into n. And what happens when we have 10 to the power 5 as n and 10 to the power 5 as q? This product comes out to be about 10 to the power 10. So basically, for a huge array of size 10 to the power 5 and for 10 to the power 5 number of queries, will not be able to solve it. So if you know bits and pieces of programming, then you would know that the time complexity permissible one is when the number of operations are within 10 to the power 8. So if the number of operations go beyond 10 to the power 8, there is a high chance that your code will get a TLE, right? So yeah, basically if we write this brute force, we will get a TLE. That is essentially the point. So we think about optimizing it, and generally whenever there is a question with queries, the way to optimize is to pre-compute something in the beginning and then try to answer every query fastly. So probably in O1. Okay. So for that, let me introduce the concept of prefix sum. So what does prefix sum says? Basically it says, let's take the cumulative sum of all the elements one by one. So let's call it S. So for 0th element, there is nothing as cumulative sum. So 0. This is like a extra element in the beginning. Then when I include the first element, it becomes 2 cumulative sum. Then 2 plus 1, 3, 3 plus 3, 6, 6 plus 5, 11, 11 plus 10, 21. Then 21 plus 7, 28. Then 28 plus 3, 31. So this is how my cumulative sum array would look like. So every element is that element plus the cumulative sum that we have calculated in the past, right? So that is how we can calculate cumulative sum. Okay, what is the benefit of this cumulative sum? Okay, what is the benefit of this cumulative sum? So let's visualize that. So now, when someone asks us what is the sum of all the elements from third element to, let's say, fifth element, then what I can actually tell him is that sum from third element to fifth element is nothing but sum from starting till fifth element, all the elements from the start till fifth, and you subtract out sum from starting till second element, right? Why? If we want a sum of a chunk, right? If we take all the elements from start till the end of this chunk and subtract all the elements sum from start till before starting of this chunk, remember, not including the starting, right? Before it. So that is why we have written 0 to 2, not 0 to 3, right? So once you do that, that means you are just left with the elements that were there in your chunk, right? And that is what your result would become. So essentially, if we had the cumulative sum array with us, which is this S array, then my answer for this query from L to R would go like sum till R, prefix sum till R. That means sum of all the elements from 0 to R minus prefix sum till L minus 1, right? L minus 1. Very important to note, here our L and R were 0 indexed. So L was, let's say, 3 and R was 5. But in prefix sum, since we have added an extra element, which is 0, right? So an extra element 0. So everything will shift by 1. So actually you would not do 5 minus 2, but you will in this array do 6 minus 3, because everything is shifted by 1 because of that additional 0 that we added in the beginning. So just one small tweak to keep a look at, right? That your array shifts from 0 indexing to 1 indexing. Like the 0th element shifts to first element shifts to second, so on and so forth. So if your original array was in 0 indexing, then this array becomes 1 indexing, right? Just to avoid this confusion, very good idea. Whenever you realize that you're using prefix sum, just prepend a 0. So as soon as you prepend a 0, now everything is 1 indexing, right? Every index matches. So yeah, that is about prefix sum. So let's look at one question based on this idea, which was this one. This was from one of the recent contests, closest cities, right? From a code forces contest that actually use this concept. So it says, let's say we are given n cities, right? So we have n cities located at 1, 2, 3, 4, 5, like points together. Okay. So yeah, basically cities are numbered from 1 to n. So for example, this array represents 5 cities of mine, and array of I represents its position. So city number 1 is at position 0, city number 2 is at position 8, city number 3 is at position 12, right? Another thing that is given is that the ordering of the city's position is defined. So every next city would be at a position greater than the previous city. So that you can see in this array as well. 8 is greater than 0, 12 is greater than 8, 15 is greater than 12. Simple, right? Now you will be given Q queries to answer, right? Q queries to answer, which ask you the number of coins that you have to take to go from city number L to city number R. So for example, from 1 to 4. If I talk about it, if I have to go from 1 to 4, what is the idea of the coins? So the idea of coins is, for a city, the city which is closest to it, you'll have to pay 1 rupee for it. But the city which is farther from it, you have to pay the difference of the positions of these cities, right? So as an example, if I look at 8, right, there are two cities which are closer to it. One is 0, which is at distance 8. One is 12, which is at distance 4. So going to 12, you will have to pay 1 rupee because it is the closer one. But going from 8 to 0, you have to pay 8 minus 0, which is 8 rupees, because it is like going back. So that is the idea of this question. And you have to calculate how many coins would you have to pay. So let's take this example from 1 to 4. So 1 to 4, we are at 0. We want to reach 4. So 0 to 8. 0, the closest city, it's 8 only. There is no other city. So the answer is 1. We have to pay 1 rupee to go to 8. From 8, we have two options, 0 and 12, out of which the closer one is 12. So going from 8 to 12, it is again 1 rupee. So 2 rupees so far. Similarly, for 12, there are two options, 8 and 15. 8 is at distance 4, 15 is at distance 3, so 15 is closer. So again, going to 15 is just 1. So answer is 3. We have to spend just 3. 1 to 5, we have already calculated for going to 15. The answer was 3. Now going from 15 to 20, you can either go 15 to 20 or 15 to 12 from 15. So 15 to 12 is 1 rupee, but 15 to 20 is 5. So you have to pay 5 more. So 3 plus 5, which is 8. That is the answer for this one. So yeah, you have to basically answer these queries faster. Okay. Brute force for this is simple. Whatever your L is, whatever your R is, there are two options. Either L will be previous, R will be like later. So L will be smaller than R. In that case, what you would need to do, you would need to iterate from L to R. For every element, calculate whether this is closest. If yes, plus 1. If not, plus the difference, right? So simple loop going from L to R. If it's the other way around, then you'll go from R to L. But the same idea, right? Same idea that either you will go forward or you will go backward and just keep on calculating the results. Okay. But how can prefix sum help here, right? So if you think about it, it's kind of like the same problem of doing sum, right? That we did in the array. But now, before doing sum, we need to calculate a special value, which is, will it be 1 or will it be the difference of the object? So just using that, we can do the cumulative sum. So let's look at it. So for example, if I take 0, 8, 12, 15, 20, let's take this case, 0, 8, 12, 15, 20. Okay. So now, to go from 0 to 8, I need to just spend 1, right? To go from start till this 8, I need to just pay 1. Going from 8 to 12, I need to pay 1 plus 1 more because closest city to 8 is 12. It is not 0, right? So going forward to 12, I'll just have to pay 1 more. Similarly, going from 12 to 15, I just need to pay 1 more. So 3. And now going from 15 to 20, I need to pay 8. So this is my prefix sum array in a way. I'm just doing sum of the number of coins that I need to pay from 0 till any point. So if I want to calculate from 1 to any point, so let's say someone asks me how many coins you would need to pay from 1 to 3. 1 to 3. So what I would do is the result for 3, which is this 3, minus the result to reach 8, right, which is this 1. So 2 coins to go from 8 to 15. So prefix sum till R minus prefix sum till L. Not L minus 1 here, because what is L minus 1? Reaching from start till this L minus 1. But actually I want to remove all the cost to reach this L itself. So slight twist or slight change here, that you'll do minus of prefix sum till L and not L minus 1. Okay. But what about the opposite cases? For example, someone asks you how many coins you need to pay to go from 0, 1, 2, 3, or actually one indexing is there. So from 4 to 1 or 2, right? 4 to 2 backward. So for that you need a suffix sum in a very similar fashion. So S sum. So if you think about it, how would suffix sum look? Last index, we don't need to pay anything to reach the last index. We are already there. So 0. Okay. Second last index 15. So 20 to 15, cost will be 1 because that is the closest city. So cost will be 1. 15 to 12. So 15 to 12, 15 to 20 versus 15 to 12. 12 is 3, 20 is 5. So 12 is closer. So answer would be plus 1. One more coin. So 2. Then 12 to 8. 12 to 8 is 4. 12 to 15 is 3. So 12 to 8 is a farther city. So I'll have to pay the difference, which is 4 rupees. Right? So plus 4, which is 6. And finally 8 to 0. So 8 to 0 versus 8 to 12. 8 to 0 is the farther city. So I'll have to pay 8 more. So 8 plus 6, 14. Right? So you need a suffix sum so that you can calculate the reverse also. So now the answer for 4 to 2 would be answer of 2 minus answer of 4. So answer of 2 is 6 minus answer of 2. Answer of 2 is 6 minus answer of 4 is 1, which is 5 rupees. And you can see also from 2 to 1, 1 rupee to go from 15 to 12 and 4 rupees to go from 12 to 8, which is total 5 rupees, right? So this is the magic of prefix sum, which lets you calculate the result from the start till any point, and with that help, calculate the result for the middle chunks. Similarly, you can calculate the result from end till any point, and again use that to calculate the result for the chunks. Okay. So great. That is the main idea. I'll try to post 2 more problems for you to attempt using this concept. So yeah, take a look at those, try it out, right? Make sure that you code prefix sum on your own. Make sure you code this closest city problem. It is a very interesting problem. And yeah, so do subscribe to the channel, like the video if you enjoyed the concept, and see you guys in the next one where we discuss a new pattern now.